Namaskar friends. So we are currently in the 8th week of our discussion on the topic operations management, and today is 37th session in which we are going to cover the PERT problems. In our 8th week our focus is on project scheduling or project management using the concept of PERT. In last week we focused on critical path method, usually we call it as CPM, and we tried to solve different problems using the critical path method. We have seen that how to construct a network based on the information available with us. We have also seen what is the Fulkerson's rule for numbering of nodes. We have seen that how a critical path can be calculated, how the early start, late start at every node can be calculated, how early finish, late finish, early start, late start can be calculated, how we undergo or how we perform a forward pass, how we perform a backward pass, what is a critical path, what is the importance of critical path. So with all that background, we are now trying to understand the problem where a element of probability is also introduced. So the overall objective of using a network is the same. In CPM also our objective is to find out that how much time this project will require, which are the critical activities in the project on which we need to focus our energy as well as our attention. Then how we can manage our resources, how we can allocate our resources in order to complete the project well within the stipulated time. So same objectives we have in case of PERT also. In PERT also we construct a network, we try to find out the critical path, we focus on the critical activities, we try to find out the probability of completion of the project, because now here there is an element of probability. Every activity, as we have seen in the previous session, has got 3 time estimates. We have got a pessimistic time for each activity, which is the largest time estimate for that activity. We have a most likely time, and we have an optimistic time, that is the minimum time that we feel, that we foresee that the activity may take. So every activity has got 3 time estimates, and overall project duration will also have a variance, because some of you may say that if we calculate the overall project duration based on the optimistic time of each activity, we will get a smaller project duration. If we calculate the project duration calculating the only considering the pessimistic time of each activity, we will get a different project duration. If we focus on the most likely time of each activity and calculate accordingly, we will get a different time duration for the project. So therefore there is a variance in the completion of the project time or the project completion time. Therefore we calculate the variance for each activity, the standard deviation is calculated, and based on that we find out that what is the probability that the project will be completed within maybe 2 days of the estimated time, or before time, or after time. Another term that we usually consider in case of PERT is the criticality index. In criticality index, we run the simulations maybe number of times considering different time estimates for each activity, and then we try to figure out that what all are the activities that are going to lie on the critical path. Now suppose we run 1000 times simulation program, and out of 1000 time there is an activity which is always falling on the critical path. So we can say that the criticality index of that activity is 1, because 1000 times the simulation has been run, and all 1000 times that particular activity has fallen on the critical path. So one, maybe to explain that, I can just draw one diagram based on which you will be able to appreciate this concept of criticality index. So suppose we have a network like this. So in this network, if you see, we can number the nodes as so if we calculate, if we see that what are the number of paths available from the start node to the end node, you can see we start from here and this is the last node for this project network. And how many activities are there? Suppose we number the activities as A, B, C, D, E and F. So we have on this project, we have 5 activities that have to be completed in order to ensure that the project is completed. Now we can have time for each activity. In case of PERT, we will have 3 time estimates for each activity. For A, we will have 3 time estimates. One will be the pessimistic time, then the most likely time, and then the optimistic time. So we will have 3 time estimates for each activity. Similarly, we will have for B, C, D and E as well as F. So you can see 3 time estimates for each activity, 5 different activities. How many combinations are possible? There are number of combinations that are possible. So we can run a program and taking individual time for each activity and find out that what is the critical path, and then we can find out that which activity is lying always on the critical path. And in this network, if you see, we can just see the number of paths in the network. We have one path A, C, E and F. We can write it as A, C, E and F. Another path can be A, D and F. Another path can be B, E and F. So I think these are the 3 paths that are available in this network. If we start from A, D and F, A, C, E and F, and B, E and F. So there are 3 paths only available in this network, and you can see that activity F is on all the paths. So we can say that if we do the simulation using different time estimates for each activity, if we run maybe 500 simulations, activity F will always fall on the critical path. So the criticality index for activity F can come in the simulation as 1 or the highest, and the highest criticality index activity we have always to consider. We have to always focus on that activity, because any delay in this activity will delay the overall completion of the project. So whenever there is an element of probability involved in each and every activity of the network, it is very difficult to calculate the overall project duration, and that is why sometimes we take help of the computational tools to run the programs and try to see that which all activities are lying on the critical path, or which, in other words, we can say that what are the activities which have the maximum probability of falling on the critical path, so that we focus only on those activities in order to ensure the completion of the project well within the stipulated time. So this is just one example to emphasize the importance of these 3 time domains, or these 3 time estimates that we take in case of PERT for each and every activity. So similar type of problem we will try to cover today in our discussion, and try to figure out that how we can calculate the probability of the completion of a project within a fixed time domain. We can see that the probability will keep on changing as you keep on changing your expected duration of completion of project. So first we will calculate the estimated duration of completion of project, that will be based upon the estimated time for each activity. If you remember, in the last session we have seen that based on these 3 time estimates, that is T T pessimistic, T most likely and T optimistic. So we have three time estimates: T optimistic, most likely and T pessimistic. We calculate an expected time for each activity, and based on the expected time for each activity, as we do in deterministic time estimates in case of CPM, we will calculate. What we are going to calculate? We are going to calculate the overall project duration, and based on that we will then further find out the probability of completion of the project, maybe 2 weeks prior to, or 2 months prior to, or 2 days prior to, or 2 hours prior to, whatever is the time unit we have taken completion of the project. For example, the estimated time for completion of the project is 24 days. So we can calculate, as we have seen in the last session, what is the probability of completion of the project within 22 days, or what is the probability of completion of a project within 26 days. So that probability we can very easily calculate, because PERT, as I have told earlier, is probabilistic in nature. So with this background and the emphasis on the three time estimates and the element of probability involved in estimating the overall project duration, I think the concept of criticality is very important, and that I have tried to explain today. Rest, the mathematical part of the calculations are easy and can be done by all the learners. And why do we need to do these type of calculations? Because always we need to focus on the critical activities in order to ensure the timely completion of the project. So let us now run through our presentation for today and try to understand one simple problem related to PERT. So friends, let us take an example. On your screen you have one example in which it is a small project that is composed of the following activities whose time estimates are given. So you can see the easiest way of drawing any network is that we know the nodes, the start node and the end node for every activity. So this is the easiest way, as in case of critical path method also we have seen this way of representing our network. Also we have seen that there are two major ways of representing any network. One is activity is on the arrow, another one is activity is on the node. So here in this case 1 2 means this is 1 2 is the activity, the 1 and 2 represent the node, that 1 is the start node, 2 is the end node for the first activity. Similarly 1 3 is another activity starting at 1 and finishing at node 3. So this is one easiest representation, because when we have the precedence relationship given, we have to first construct the network satisfying all the precedence relationships. So that additional job is added for constructing the network, and sometimes we have to use the dummy activities also in order to ensure the logic of precedence relationships. But this is the simplest way of representing a network, and it is easy to construct the network as in this case. So how many activities are there? We can count. You can see that there are 7 activities in this project. So we have the optimistic time, the most likely time and the pessimistic time for each and every activity, and these 3 time estimates we are going to make use of when we are going to calculate the estimated time for each activity. And if you remember, in the previous session we have taken that estimated time TE is equal to TO plus 4 times TM plus TP divided by 6, where TO is the optimistic time, TM is the most likely time and TP is the pessimistic time. So TO plus 4 times TM plus TP divided by 6. So these 3 time estimates we are going to convert into the estimated time for each and every activity, and based on that we will calculate the critical path for the activity, and then we will see that what is the probability of completion of the project within that stipulated or calculated time which we have calculated from the critical path. So we will have a problem at hand now. Now, what is the problem? One is the information that is available with us. In order to explain it in the most simplified manner, we have taken a network in which the node numbers are already given. The activities are being represented by the start node and the end node. So, there is no problem whatsoever in constructing the network. So, it is easy to construct the network. Similarly, the 3 time estimates are also given. So, based on that, what is desired, what we need to calculate? So, we need to calculate 3 things here. What is the probability that the project will be completed under 3 different conditions? So, first is at least 4 weeks earlier than the expected time. So, friends, from where we will get the expected time? Expected time, as I have already told you, we have 3 time estimates. From these 3 time estimates, for each activity we will calculate the expected time. So, now we will have 7 time estimates only, because our project consists of 7 activities. So, for each activity we will calculate the expected time. How we will calculate? All of you know the formula for calculating the expected time. Now, once we have calculated the expected time for each activity, now for 7 activities we have 7 expected time. Now, we will see what are the different paths in the network. Based on that, we will calculate the critical path, and once we know the critical path, we can very easily find out, or we will be very easily able to establish that what is the expected time. So, our first job will be to calculate the expected time. Now, the first question is that what is the probability that the project will be completed at least 4 weeks prior to or earlier than the expected time that we have calculated from the critical path. Second problem, not more than 4 weeks later than the expected time. So, we have a expected time. We wish to calculate that what is the probability that the project will be completed 4 weeks before the expected time. What is the probability that the project will be completed at least 4 weeks after the expected time. And the third problem at hand is that find the project duration at 95% probability, that how many weeks will or how many hours it will require in order to, in this case our problem is in weeks. So, here we are dealing with weeks, sorry I initially mentioned hours. So, we have to see that how many weeks are required in order to ensure that 95% probability is there for completion of the project. So, we can see that now we can calculate different things related to the project duration. And why, means another thing that comes to my mind is what is so important about the project duration. Mathematically it is easy, all of you have understood that we have a piece of information, a tabular form of data available with us. Based on that we draw a network. Based on the network we do some arithmetic or mathematical calculations, and we find out that what is the critical path. Then in case of PERT, as I have drawn the diagram, this network and shown that there are number of permutations and combinations possible. There is variance, there is standard deviation related to the completion of the project, because here we are not having deterministic time estimates for each and every activity, we have probabilistic time for each and every activity. So, therefore, we need to calculate that what is the maybe probability of completion of the project. So, mathematically whatever I have stated is absolutely correct. But as a decision maker, as a strategist, how I can make use of all these mathematical calculations? That is the most important thing. Once I know the critical path, first and foremost thing is all my energies must be focused on that critical path or the activities that are lying on the critical path. The second most important decision is that when you are in business, you will be focused on both the ends. You have to deal with your raw material suppliers, with your vendors. On the other side, you have your customers, you have your dealers, you have your retailers. So, you are pressed from both sides. So, in overall business cycle, we must know that what is going to be our project duration. And once we know that, we can negotiate, we can do hard negotiations with our vendors. We can be very, very confident with our customers, with our dealers, with our warehouse managers, because we know that as per my calculation, as per my mathematics, the project must be completed. There is 100% probability that the project will be completed within this many number of weeks or this many number of months. So it is not just a number, it is basically going to help us in formulating our strategy related to management of our overall operations within the organization. So we must not just see that some mathematical calculations we are doing and how these are going to affect the operations. So we must address and we must understand that this is not purely mathematics, that this is going to help us in our decision making related to the operations management. So here I have tried to emphasize on the importance of these probabilities, that is, what is the probability of completing the project 4 weeks before the expected time, what is the probability of completion of the project 4 weeks after the expected time or estimated time. Then if we want to ensure that I have to be 100% sure that the project has to be completed, what is the duration for ensuring maybe 98, 99, 100% completion of the project. So that number of weeks, number of months we can also calculate mathematically. So here we have a problem at hand where we have 3 different calculations to be done. So first and foremost, when you have a project data available with you, you have to construct a network. So here this is first stage, because as we have seen, each and every activity in case of PERT will have 3 time estimates. Based on those 3 time estimates, we will calculate the expected time for each and every activity based on the formulation or formula that we have seen in the previous session. So that formula is being used here, that is TP plus 4 times TM plus TO divided by 6. So based on that we calculate the expected time for each activity, and similarly we calculate the standard deviation for each activity. So this is the table is showing you expected time and standard deviation for each activity. And why standard deviation is being calculated? Because if you remember in the previous session we have seen, in order to calculate the Z statistic we require the standard deviation, we require the expected time of project completion, and we require the expected time, plus we also require that the time for which we want the project to be compared, that what is the probability that the project will be completed within 28 weeks or 30 weeks. As in our case, we have to first calculate that what is the expected time for the completion of this project. So first and foremost we have to calculate the expected time for each activity, standard deviation for each activity. Then we have to network, we have to construct. This is the most simple form of the network, as the node numbers are already known to you, 1 2 1 3 1 4 3 5 5 6. So this is we can calculate, and then we can very simply see like the easiest method of finding out the critical path. If we do not want to go into the calculations of early start, early finish, late start, late finish, we can calculate for the different paths what is the time required. So 1 2 5 and 6, 2 plus 1 3 plus 7 10, 1 3 5 and 6, 6 plus 4 10 plus 7 17, 1 4 6, 3 plus 5 8. So we see 1 3 5 and 6, 4 plus 6 plus 7, that is 17 is the longest path. 1 3 5 and 6 thus becomes the critical path, and the expected time for completion of this project is 17 weeks. So first thing we have already done. What we have done? First we have calculated the estimated time or expected time for each activity. Then we have constructed the network. Based on the expected time for each activity, we have calculated the critical path, and our critical path has been highlighted here, 1 3 5 and 6, and the time is 17 weeks. So this is our critical path 1, 3, 5 and 6. Now this formulation we have seen in the previous class. Z statistic is equal to x minus mu divided by the standard deviation. X and mu you know. So we calculate the sigma net, which is a summation of maybe the standard deviation of the activities that are lying on the critical path. So for the first problem was that we have to calculate that 4 weeks prior to the completion or prior to the expected time. So 4 weeks prior to the expected time of project completion. So project completion as per our critical path we have seen the expected time is 17 weeks. So 4 weeks prior to that is 13. So 13 minus 17 divided by the standard deviation of the project of the activities, summation of the standard deviation of the activities lying on the critical path, which comes out to be 3. So 13 minus 17 divided by 3. So the Z statistic, that is Z x minus mu divided by standard deviation. So mu is our expected time, x is our variable which we have taken 4 weeks prior to the expected time, that is 17. So 13 minus 17 divided by 3 comes out to minus 1.33. So hence the value of Z from the distribution curve from the data table is 0.0918%. So the probability of completion of project in 13 weeks is 9.18% only. So we have calculated that expected time is 17 weeks. We are calculating the probability for completion of the project in 13 weeks, which is 9.18% only. Now suppose we have to calculate 4 weeks after the expected time. Expected time remains the same, that is 17. 4 weeks after means 17 plus 4, 21 weeks. So 21 minus 17 divided by 3. So it comes out to be 1.33, and I must say that is divided by 3 is for overall 21 minus 17. It is not 21 minus 17 divided by 3. This is 21 minus 17, that is equal to 4 divided by 3, which comes out to be 1.33. As you can see in this formulation here, x minus mu divided by the standard deviation. So the x minus mu value has to be divided by the standard deviation. So here 21 minus 17, 4 divided by 3, 1.33. Hence the value of Z from normal distribution curve is 0.908, corresponding to the Z value of 1.33. So probability of completion of the project in 21 weeks is 90.82. So you can see that once we are trying to shorten the duration from 17 weeks to 13 weeks, we are getting 9.18 probability only. But when we are extending the project duration from 17 weeks to 21 weeks, we are getting a higher probability of completion of the project, that is 90.82. And the last problem is we have to calculate that what is the duration, what is the expected duration of the project, so that 95% probability is there for the completion of the project. So for 95% from the normal distribution curve, we can calculate the Z value must be 1.65. So in the previous two A and B problems, we were actually calculating Z and then seeing in the table that corresponding to that Z value that we have calculated, what is the probability. Now here probability is given to us, we are doing the back calculation based on 95% probability, we are doing the reverse calculation, what is the value of Z. So in this case Z is known to us, the expected time that we have calculated from the critical path 17 is known to us, standard deviation for the activities on the critical path is known to us, or summation of standard deviation. So we have out of the 4 things, Z, x, mu and the standard deviation. In this case Z is known to us, we have to calculate the value of x because mu and standard deviation is already known to us. So from here we can very easily calculate x minus mu, that is expected time 17 days, divided by 3, here it is correctly represented, the bracket is there, x minus 17 divided by standard deviation equal to, corresponding to 95% probability, the Z value is 1.65, and from here we can calculate that x is equal to 22 weeks. That there is a probability that if we are given 22 weeks, we will be able to complete the project. 95% probability is there that the project will be completed in 22 weeks. So you see that when we are reducing the project duration, we are seeing what is the change in probability. When we are giving more time than the expected time, the probability of completion is increasing, and further x is increasing. So last calculation that we have seen for x is equal to 21 days, we have seen that probability is approximately 90%, but here we are seeing that if further one additional week we spend, the probability increases to 95%. So PERT can give us a probabilistic estimate of completion of the project, and this can be helpful for the managers of an organization to plan their operations accordingly. So with this we come to the end of today's session. In next session we will try to address a different problem based on PERT. Thank you.